Hello friends, it's a Friday and we meet again. Today, our discussion topic will give you all an in-depth knowledge of controls. Hope you are liking our videos. If you have any suggestions or ideas regarding this content videos, please write to us or reach us via social media. Our social media links are provided in the description box. So let's get started with our content today with being Atrija, your learning buddy. A brief introduction to controls. What is control? It is a function of control system to measure the process variable, compare it with the set point, and take a corrective action to minimize the error in measurement. Control has 3 steps, that is, first measuring the data, then processing the data, and finally causing a control action. This is a self-explanatory diagram. Kindly have a look. Basic control loop principles. According to those principles, controllers can either be open loop or closed loop. Closed loop provide feedback, whereas open loop doesn't provide feedback. Open loop control, also referred to as non-feedback system, is a type of continuous control system in which the output has no influence or effect on the control action of the input signal. In other words, in an open loop control system, the output is neither measured nor fed back for comparison with the input. An open loop system has no knowledge of the output condition, so cannot self-correct any errors it could make when the preset value drifts, even if this results in large deviations from the preset value. There is no feedback mechanism in the control loop. That is the reason why this control loop is usually not recommended. Please refer this example of a dryer. The timing controller continues for full 30 minutes regardless of the fact that the clothes are not heated or dried at the end of the drying process. This is because there is no information fed back to maintain a constant temperature. Moving on to the next control is closed loop control system. Closed loop systems are designed to automatically achieve and maintain the desired output condition by comparing it with the actual condition. It does this by generating an error signal, which is the difference between the output and the reference input. In other words, a closed loop system is a fully automatic control system in which its control action being dependent on the output in some way. The sensor in this case would monitor the actual cloth dryness and compare it with input in reference or set point. Accordingly, controllers makes the necessary correction to the heating system to reduce any error. For example, if the clothes are too wet, the controller may increase the temperature or drying time. Likewise, if the clothes are nearly dry, it may reduce the temperature or stop the process so as not to overheat or burn the clothes. Now, there is a direction of control action. A control action can be either direct or reverse acting. The function of respective controller in the control loop is to keep the control variable high, reverse acting, keep the control variable low, direct acting. Reverse action is used for heating application. That means if the room temperature goes down below the set point, then heating control variable will open. Direct action is used for cooling application. That means if the room temperature goes above the set point, water control variable will open. Moving on to the next control system, it is on or off control system. It is the simplest form of feedback control. An on-off controller simply drives the manipulated variable from fully closed to fully open depending on the position of the controlled variable relative to the set point. A common example of on-off control is the temperature control in a domestic heating system. When the temperature is below the thermostat set point, the heating system is switched on, and when the temperature is above the set point, then heating is switched off. With the use of low-cost, simple on-off controller, only two control states are possible, like fully on or fully off. It is used for limited control application where these two control states are enough for control objective. However, oscillating nature of this control limits its usage, and hence it is replaced by PID controllers. A PID controller continuously calculates an error value as the difference between a desired set point, that is SP, and a new measured process value, that is PV, and applies a correction based on proportional, integral, and derivative terms, PID respectively. P control or proportional action. Proportional control in process control is a type of linear feedback control system in which a correction is applied to the controlled variable which is proportional to the difference between the desired value, that is the set point or SP, and the measured value, process value, that is PV. Increasing the P band makes the controller output sluggish. Next is I controller or integral action. Due to limitation of P controller, where there always exists an offset between the process variable and the set point, I controller is needed, which provides necessary action to eliminate the steady state error of time until error value reaches to 0. It holds the value to final control device at which error becomes 0. Integral control decreases the output when negative error takes place. It limits the speed of response and affects the stability of the system. Speed of the response is increased by decreasing integral gain. I controller doesn't have the capability to predict the future behavior of the error, so it reacts normally once the set point is changed. D controller or the derivative action overcomes this problem by anticipating the future behavior of the error. Its output depends on rate of change of error with respect to time, multiplied by derivative constant. It gives the kickstart for the output, thereby increasing system response. So that's it for today. Hope this content gave you a good insight into controls. We will meet again on next Friday with yet another interesting topic. So stay tuned, take care, and bye-bye.